Okay, it's time. Hear me correctly? Good afternoon. I'm really happy to be here. It's my first presentation here in London. So welcome. And we're here to explore together why and how to create a CLI plugin. But first of all, what's a CLI? CLI stands for, of course, command line interface. It's ugly to look tool, but very useful, actively developed by Salesforce team, and created to interact with various type of orgs, sandbox, scratch orgs, and of course, production. It has a lot of possibility, a lot of out-of-the-box commands bundled in it. It's deeply integrated with the native operating system tool like PowerShell for Windows or terminal apps for Linux and macOS. But why use a command-based tool when we have a Lightning experience? The main reason is automation. The CLI is not good looking, but very useful, as we said, and it's created to make life easier for developer, especially to automate repetitive tasks like run test, install package, create scratch org, and so on. It's natively integrated and flexible, and it's developed on a modular architecture, and it's support easily customization and extensions. But in some cases, we require some more complex operations, and often the solution may be to create an extension called a plugin. Let's explore some use cases where the creation of a plugin may be useful. For example, to create an Apex code coverage for our classes, to convert profiles to permission sets. This is an example of local commands. We don't interact with org during this operation, but only with your local file system. Or if you want to import large data into, for example, a pick list, a large number of values with labels and API names difference. Let's take the example of Cody, and let's answer this use case. Yeah, thank you. Hope so. So, luckily we have a dedicated command to create a plugin. So SF. Do you see correctly the command line? Yeah, okay. Generate plugin. It's an interactive command, so we need to answer some questions. So no, I'm not an internal Salesforce team. SFDX DNS call 24. Oh no, sorry. It will not be named correctly. We're not yet in 2.45. Description, create an Apex code coverage, myself. And let's use the default code coverage for this plugin. I know it's bad in real life, but just for this demo. It will create a lot of files needed to have a fully functional plugin. Okay, it's done, so very quick. The first thing we have to do to use it, it's to link this new plugin to our local command line. Plugin, link, and the new folder just created. Okay, it's done now. Now I can open it in my favorite code editor. Yeah. Can you see? I can zoom. Is it okay? Yeah. Okay. Yeah. I know. I need to apply my last updates. So as you can see, a lot of files has been created, but the most important is the RSC folder containing all the commands. The new plugin is a simple Hello World plugin, but it's still fully functional. So I need to create a new command, and we have also a new command for that. Dev generate command. And I need to provide a name for that. Let's say Apex coverage report. Adding columns will define different nested subfolder. Yeah. So it's created a new Apex coverage subfolder and the report file. It's written in TypeScript. It's an extension of JavaScript. So this is the same Hello World simple plugin, but we can use it as is. So we want to give the ability to user to interact with an org. So we need to provide a way to say which org we want to interact with. So let's use the standard definition for all the other commands. Let's say for the flag target org, and we have a dedicated command also to create a flag. Yeah, I want to use the new flag for my new command, and we have different options here to create already built-in type of flags. For example, let's say required org. It's a standard flag, so I will keep the standard definition. Yeah, it will be named target org. So as you can see, it's already created. The second flag I need to create is the API version. So I will use the same command, but with different option. Org API version is, yeah, API version. And next, I want to create a flag to set the output format of the report. So let's say it's an option format report output format, and let's say we will use the F character. It's not required, and I don't want to be used multiple times. Now I'm prompted to enter the options. Let's say CSV, JSON, and HTML, and that's it. Okay, so everything is set. So now we can add some logic to our plugin. We don't use this line. So the first step is to gain a reference to our org. So get connection. The plugin generator is based on Salesforce library, which gives us a lot of classes and methods to interact easily with the orgs. So for example, to get a connection here, we use the target talk flags and invoke the get connection. With only one line, we have a reference to our connection. Then we retrieve the whole Apex class list. The same principle. We use the connection and we invoke the metadata API with the Apex class subject. This list contains all the classes from our org, including test class, which not be relevant for our report. And we don't want also to include classes from managed package, so I need to exclude them. So with this condition, I create an array of Apex classes, and I don't want to, I want to include them only those whose manageable state is equal to unmanaged, and I exclude those who contains underscore test, which is my naming convention for test class. Let's test it for. So first of all, I need to compile yarn build, and then I can invoke the command as it linked with my local command line, sf apex coverage report -o like other commands. DNS. This is my special org for this demo. And as you can see, we retrieve the whole list of Apex class. So I need to comment out this. This is, we can sort on the class name. So one-liner again, easy in JavaScript, provide a comparison method, and then the Apex class array will be sorted. Then we need to retrieve the coverage. For this, we invoke the tooling API, and as seen previously here, with Salesforce is quite easy. One line, we use the connection reference, invoke the tooling API, and the Apex code coverage aggregate object, which contain the code coverage for each class. Now I have the class coverage list. We need to create a temporary data structure to be used to create the report later. So don't be afraid. This is a lot of lines, but quite simple. So I create a coverage list, and I iterate over the Apex class and retrieve the class coverage from the org based on the Apex class or trigger ID field. If I found a record based on this ID, it means that this class has been covered by at least one test. So I calculate the coverage percentage here and create a progress bar and add a custom object containing all the properties that I want to display on my report. Class ID, the class name, the number of lines covered and uncovered, the coverage I just calculate here, and the progress bar. If I don't find a coverage record, it means that this class hasn't been covered by any test. So I need to display this information in my report. So I still create an object, a temporary object, but with coverage equals to 0. Now that I have the data structure, I can create the report. So with the simple switch statement with all the three output format, let's say the CSV. To create the CSV, first I extract the object keys, property names to create the column headers for the first line of the CSV. And then I iterate over the coverage elements, extracting the values and joining by a comma. This is hard-coded, but we can imagine create another flag for the command, giving the ability to user to pass which character they want to use to separate fields. For the JSON format is even simpler, as the temporary data structure is already a JavaScript object. So I just need to stringify the object, and I added some tabulations here. Let's see what's happened now. F CSV. Oh no, I forgot to build again. And with CSV format. So as you can see, I have generated all the property fields, property names, sorry, here, and then iterate over all the classes. The advantage of using a CLI is that we can easily redirect the output to a file with just some additional parameters. So I can now have a file containing all the data. And with the JSON, let's see. Yeah, so we can archive, we can name it based on the date, based on the release name, for example. For the HTML format, we need to write a little more code, but the principle is the same. We create the headers by iterating over the keys. Then we create the body by iterating over the values. I just added two little things here. One is if the coverage is equals to 100%, I will color the progress bar in green. And if the coverage is under 75%, the whole line will be highlighted in red. But the rest is just markup. And then I create the whole markup for the page. I import the CSS from Lightning Design System to give a good look for my page. The important thing here is the HTML table with the headers and the body. And let's see how it's look like. So as you can see, the 100% here is colored in green, and we clearly see that this one should be reviewed and this one too. Okay, so now we have a new and shiny plugin. We want to share with the community. So as it's based on Node.js, it's provided with NPM, Node Package Manager, and NPM gives us the NPM publish, a command which publish the current folder to the npm.js website, so that the community can then install it and use it. And that's it. If I go to the npm package, and it's here. It may take some minutes, some moments to be indexed by the search engine, but it's here, and then you can install it. You can find here some references, useful documentation about Salesforce, NPM.js, and so on. Some trail on Trailhead to explore the creation of plugins, and you can see here you can find then the link to the new plugin that we created together.